All right, moving right along because you got a lot to do. So we're going to just talk about whether graphs or tables are proportional or not and how you know. So how would you know if a relationship is proportional or not? Well, the whole idea behind proportion is that you're doing the same thing over and over and over again, right? And it's typically with multiplication because that's a repeated step. Okay, so with graphs, the way that's shown, okay, without you having to really even look at the numbers or anything, a graph of a proportional relationship has two things. There's two things you got to check off. It has to be a straight line, okay, a straight diagonal line. It could go whatever direction. It just needs to be a straight line that goes through the origin, which is 0, 0, right? It has to go through there. Okay, because if it doesn't go through there, then that means something got added or included somehow or subtracted somehow or whatever. That's not going to allow it to go through 0, 0. Okay, so you have to have a straight line that goes through the origin. So we're going to do some graphs here in a second, but I wanted to talk about tables as well. Tables follow a similar idea, but you can't see it the way the graph is showing. You're not going to have a straight line or origin. Although if you do see 0, 0 and you see the proportion happening each time, then that is a good sign that it's probably going to be proportional. But anyways, the table will show proportional ratios, right? So like the whole thing is a ratio, and if you treat it like a fraction, kind of like what we did with those unit rates in the last video, they will reduce down to the same fraction. I'll show you an example here in a second. But in order for tables to be proportional, they must all be proportional ratios, meaning that you can see the same comparison between the two numbers, and as you compare the numbers moving on to the table, you could get to them somehow, which means that the reduced fraction are all the same. So let's focus on the graphs first. So it says to circle the graph or graphs that are proportional. If it is not proportional, why isn't it proportional? So with graphs, again, two things. We're looking for straight lines that go through the origin. So this first one is definitely not a straight line, so I don't even have to look any further, even though it does go through the origin. It is not a straight line, so not proportional, okay? So you can just write not a straight line as your reason why it's not proportional, okay? If you want to put yes, no, whatever, that's fine, but that's the reason, okay? All right, this next one, it is a straight line, but it is not going to go through the origin, right? It's going to miss it, so that is why it is not proportional. That is not going through the origin, so it is not proportional, not possible. That means something was added to it because it's starting up here rather than down here. Okay? All right, ding, ding, ding. This one does have a straight line and goes to the origin, so go ahead and circle that one. That one is proportional. And this last one, while cool, is definitely not proportional. It is neither. It is not a straight line, and it does not go through the origin. Nope, doesn't work. Okay, so that was the only proportional graph. Very simple, 2 check marks. That's what makes it proportional or not. Now, it doesn't mean that there's not a pattern of some kind. It just doesn't mean it's proportional. Okay? All right, so talking about tables, remember you have to show that same relationship when you're comparing the two quantities. So again, we're going to circle the ones that are proportional. If they're not proportional, we'll give a reason why. So on this first one, we have, first off, I can already tell since it says 0, 5, that that's obviously not going to go through the origin because the origin is always 0, 0. So right away, I know that. But just to show you, this is going to be 0, and then you've got plus 5, right? And so there's a connection down here, right? It's going downward, it's going up by 5, and downward it's going up by 1, but the connection across is different, right? It's a plus 5, and then you've got either times 10 or plus 9, and then you got plus 13 or times 7.5. Like, it's not following a consistent pattern. So these ratios are not proportional. That's how I'm describing it, why it's not proportional, because when you compare the ratios of the hours and dollars or time and cost, it's not the same thing happening each time. Okay? All right, this next one we got, just next one why we're comparing. Ooh, good sign so far. We got 0, 0, so it would have gone through the origin if we graphed it, but we got to make sure it would create a straight line too, which is that proportional aspect with the ratios. So if I compare x to y, I'm doing 3 times 4 to get 12. 4 times 4 gives me 16. Good so far. 10 times 4 gives me 40. Yep, this one's proportional. It works. Let's see if I can get my circle. There you go. Go ahead and circle that one. That one is proportional. All right, let's look at the next one. Again, 0, 0 is a good start. We know it's going to go through the origin. All right, this one is a little bit harder to tell. Okay, you may not be able to see the pattern, or you may not know if there's a pattern or not. So here's how you can always check. Get your nifty calculator out. If you don't have it, pause the video and go get one. right? But if you have it, you can take the y and divide it by the 6, right? Kind of working backwards from what we did over here. We were going 3 times what gives us 12, but if you can't see that, if you don't know what 6 times something gives you 15 is, you can work backwards to see if that's what's happening with each one. So go ahead and do 15 divided by 6 in your calculator, and you should get 2.5. Okay, so now if this table is proportional, that means if you do 20 divided by 8, you should also get 2.5. So you should, right, if you just did it. And then try the last one, 47.5 divided by 19, because remember, it only takes 1 to make it not proportional. It might be proportional the whole way, maybe the last one all of a sudden something changed. So if you did that, it should have been 2.5 again, which means this one is, if I can get my circle to show up, proportional. Oh my goodness, I don't know where there we go. Ooh, that was really hidden. So that one is also proportional. Alright, our last one, not starting off good here because we got 0 and then 100, but let's see, just to make sure. So if you look, going down I go up by 50, and going down I go up by 1, but across there is no connection, right? Like I've got 0, I don't know, nothing that we could multiply by. So ratios are not proportional. Okay? Alright, you should have gotten the gist of that. You have a quick check to go get, so do not go on to the next page. Go get your quick check. That'll be real quick. Haha, got it. Anywho, good luck. You can do it.